Good afternoon, Tom. It's a pleasure to be here to interview you again. I know you've done a lot of commenting in your videos on the double-slit experiment, and you have commented that there are some people who still don't get some of the points to it. There are some points that you'd like to clarify. Could you do that for us? Could you give us an expansion on some of the ideas you feel are important?
Sure. The double-slit experiment, it's important for several reasons. One, as physicists today would say, it's the key to understanding how the world works. How is it that quantum mechanics acts the way it does? And of course, it's a big mystery to scientists today. But the double slit kind of holds the secrets. If you understand that, then you understand all of it. Is kind of the idea. At least Richard Feynman had made a comment to that accord. So it's important because it represents where science has run into the wall trying to interpret what the world does. They do experiments and say, how does the world work? Here's the experiment, here's how it works. And then scientists want to interpret that in terms of a physical, objective reality. But they can't. It doesn't interpret that way. If you try to make what happens a series of logical events that are causal and physical, in an objective way, it doesn't work. That's why it's a big mystery. You can't interpret what happens in the world as a objective reality. So that's their problems. And the big mystery is, why not? How is it that we can interpret this and save our belief in an objective reality? And that's what physicists have been doing now for, ever since, Bohr and Heisenberg. They've been trying to squeeze the facts into an objective explanation. Can't be done. Mostly they come to the conclusion of this is impossible, will never be done. Okay, so the double slit is this core piece of this big mystery in science. So that's one reason that it's important. But you can understand the double slit experiment very easily if you understand virtual reality. The way the double slit experiment works is a direct result of this reality frame not being objective, but being virtual. And a lot of people get lost on this double slit. They hear what happens, say, here's how the world works. It doesn't make sense to them. They say, well, that's impossible. That doesn't make any sense. What about this? What about that? And they hear the idea that, well, it's a consciousness has to, take a measurement. It's the measurement problem. It's the consciousness involved in it. It's the consciousness is creating the particles. And that's not right either. You see, that's also wrong. So everybody seems to be a little confused with this. The way to understand it is to understand the nature of a virtual reality, and not only any virtual reality, but our virtual reality and the way this virtual reality works. So let me go back with this explanation and start with the tree in the woods. Now, obviously, talking here with you today, I'm not going to go through a whole, workshop worth of virtual reality and double slit experiment. I don't have any slides. We don't have any visual aids. So if you're just listening to this and haven't actually watched the videos where we talk about this, you'll probably be lost. So for those of you just listening to this, go back and do that first. Then this conversation will make more sense. But in my workshops, I talk about the old, if a tree falls and there's nobody there to hear it, does it make a sound? And that's an old riddle, if you will. And of course the answer to that is, well, there is no woods, there is no tree, there is no sound. They're all virtual. It's just information. That leaves everybody scratching their head. What does that mean? So I do a little more explanation and I say, well, let's just make this thought experiment. And there's a man who walks into a woods. That woods has never been seen before or experienced before by any sentient being of any sort. This man is the first sentient being to walk in there. And he looks around, and one of the things he sees is a tree, dead tree, standing, wobbly but standing. Okay, and then, of course, the way it goes is that he leaves, he comes back 5 years later and walks into the woods at the same place, and he sees a dead tree lying on the ground. And of course, everyone who believes in an objective reality believes that the tree must have fallen from standing to being on the ground. And the process was one of, tipping over and falling and going bang on the ground. But the point is, that's not the case, because this is a virtual reality. That's not a physical tree. It's data. It's information. The reason he saw the wobbling dead tree was because it was probable. Because in our reality, when you look at something, and we'll call that taking a measurement, you get what is, what comes out of the probability distribution. So you have a probability distribution of the things that are likely and the likelihood that they are. Then you take a random draw from that, and that's what you get. So what he got was this wobbly standing dead tree. He comes back 5 years later, and he looks, he sees it lying on the ground, not because it fell over, but because it's probable that it had fallen over. So he gets the data in his data stream of a dead tree lying on the ground. You see, he had first in his data stream a tree standing up, second in his data stream a tree lying down. It didn't have to fall. There is no physical tree. It's just information. So that's how that, that's how that works. Well, then we take that a little further. He goes, let's say now we're starting this over. He goes into the woods, he sees the tree, and it's wobbling, and he leaves the woods and immediately is eaten by a bear. That means now the information of what that woods looked like is gone. And now somebody else comes in the next day and walks into that woods. Would they have to see that dead tree? No. They wouldn't have to see that. There will be another set of probabilities of what might be there. A random draw will be taken, and they will see whatever comes out. It might not have to be that same thing. How can that happen? Because there really is no woods there in the first place. It's just information, and our reality, rather than being objective, is probability and statistics. It's what's probable is what we see. So here we are with as an individual person with a data stream, and we get that data stream based on our multiplayer game. Now, why did he find a woods there? Because there probably was a woods there. You see, and what kind of woods was it? Well, it could have been a conifer, it could have been deciduous, it could have been very barren, because of the probability of that area, of the rainfall, of the kind of trees that are in that area, of the kind of seeds that might have been dropped. We have all of this that adds up into the probability. In other words, the history, what leads up to that. So there's certain probabilities that things will be a certain way, and then you take a draw and you get what you get. But once you get it, it's here. Once there's data in this physical reality of what you saw, even if that data is just in your mind, in your memory, there's data here, then if you go look again, it's still going to be there. So he leaves the wood, goes back, looks in, the dead tree will still be there. And he does that 10 times, it'll always be there, because once he saw it, it's here, and it will remain. Now, if he takes a picture of it, of course, that puts data here that he can share with others other than just his memory. But the point is, data comes in. Once the data comes in, then it has to be that way, because now the probability of it being that way is 1, because the data's been produced. So the reality, the generation of this digital reality requires consistency, historical consistency. Now let's go to the double slit, and we'll see the double slit is the exact same thing as the man and the tree and the bear. It works exactly the same way. The natural state of reality is probabilistic and statistical. Okay, this is a multiplayer game. So now you have scientists in a double slit, and they're going to throw, say, electrons at this double slit. Okay, now they throw electrons at a double slit. If they throw them just one at a time, okay, then the electron will do something. It'll go through slit 1, slit 2, or not. Now, if they measure at the slits, what slit does it go through? If that's where they take their measurement, then they see an electron going through slit 1. Well, later, or once they do that, then that electron has to be there. Now that information pinpointing that electron in this reality has just been created when they made the measurement. The key thing here isn't that they're conscious. The key thing here is information. You see, they've created now a piece of information that there is an electron going through slit 1. Once you create that information, in order to keep a consistent virtual reality, there has to be then one little electron on the screen, or let's say the electron makes a little point of light, if you will, when it hits or deposits a little piece of energy. There'll be that one little point of light right behind the slit. Okay? It's right behind the slit because the electron is a particle and it travels in a straight line unless acted on by some other force. There are no other forces, so it has to travel through and make a little dot. Okay, so now let's say that they don't measure. Okay, we're just doing the classical double slit. That's the man goes into the woods, you know, measures a tree by finding one, right? That's the probability. Okay. Now, so the next time they don't do any measurements. So reality is probability. When the probable reality then sees double slits, it doesn't have to make choices. It's not like, oh, it's a particle, it has to go through one or the other. It's not a particle. It's just probability. Everything is probability before it comes into here by an awareness, by you know, we say a measurement, it's really by putting data here, whether the data is because someone looks or some other means. So now what happens then is that it's probable that it could have gone through the slit. Is there some probability it might go through the other slit? It's just a potential particle that probably could go either way. So that same potential and probability continues on until a measurement is made at the screen. Now when the measurement's made at the screen, you look at every point on the screen and you say, what's the probability that there'll be light here? What's the probability you'll be at light here? Well, where that probability is high, that's where you see light. You get a diffraction pattern. The reason you get a diffraction pattern is because you have a higher probability of light being at this line of dots because of the way, because of the way the probability combines with itself, and it combines with itself like a wave. So it's just this probability wave passes the slits. It's still probability. It gets to the screen, and it leaves marks where you have a higher probability of something hitting. It leaves nothing where the probability of getting something is 0. You see, and the probability distribution, which is what we're now calling this diffraction pattern, is really a probability distribution, a probability of getting that electron to hit at a very, at a particular place. So it remains probability, in this case a probability wave, until it gets to the screen. Okay, now, so what about when the man got eaten by the bear, and that changes, that erases the information? Well, now in the double slit experiment, let's say we have a machine, and this machine is keeping track of what slit the electrons go through. It's collecting data. That data is here in our reality frame. So because it takes the data, now here's the part that this confuses people. It's taking data, and if you are to, let's say, look at that data and then go look at the screen, you'll only see 2 points behind each slit because you have data in this reality that says that's what has to happen, or it would be inconsistent. You see, you couldn't have data saying it went through these slits and then get a diffraction pattern. That would be impossible. Why would an electron going through a slit do anything but travel in a straight line? You see, it's the probability is 0. All right. Now, let's say that you take to let you know that it's not consciousness. It's not that the people are looking at the data that's the problem. Let's say the machine takes the data and the machine records the data somehow in memory, some sort of memory, whether it's a tape or a printout or whatever, but the machine measures what slit it goes through and remembers, keeps the data. Nobody looks at it, but it still has the data. So you can take that machine that has all that data in it of what slit it went through, put it in a vault, let it sit there. Go look at the screen. Nobody's seen it now. You go look at the screen, and what do you get? You get 2 points. It doesn't matter that somebody's looked or not looked at the data. What matters is, does that data exist in this probable reality? You see? So as long as that data exists, you look at the screen, you'll always get the two dots. Now, it doesn't matter how long it stays in the vault or whatever. It's just, it's available. There's information available in physical reality that says that it's particles that went through various slits. You'll get a particle distribution. So now let's say that you've put this box with the information in it in the vault. A year's gone by. The experiment's done. You know, what's collected at the screen's been collected at the screen a year ago. You know, everything's been done. But instead, you've never looked at the data on the screen. The experiment's been done, and all that data has also been stored. Now, a year later, you get out the data in the vault that was the data measuring at the slits, and you destroy it. Now, there is no data that there were ever particles there. No information. Now, when you look at the screen, what do you get? You get a diffraction pattern. There's no inconsistency. The only inconsistency is that if you believe in an objective reality, you believe that that answer on the screen was a done deal, because in an objective world it would be. This is not an objective world. It's potential particles, probable particles. What's on that screen is just potential and probable until the system has to render it for somebody. You see?
I think that might be a difficult point for a lot of people to get, because they struggle with the fact that this physical reality, this physical body interacts with this physical reality, the body sitting on the chair that's a solid object. Can you explain it from this level? Why these constraints imposed upon our physical body and upon the objects that are in it interact? And I think that might be a point that people will struggle with, how they're used to this objective physical reality. So how can you tie that concept of reality as information into this more physical world?
That's what I was doing with the man and the bear and the tree. You see, that's not this very abstract double-slit experiment. That's more of a real thing with real people. But see, it acts the same way. When the man walked into the woods, it was all just probable what he would see. Then he sees something. Once he sees it, it has to remain, because now it's data here. You erase the data, and now it's just probable again of what might be in that woods. Okay, we see that the double slit works in the same. All reality works that same way. Reality is in the what I call the future probable database, or probable future database, I should say. And that's where it is. It's just a probability. Until we get something in our data stream, until something has to be rendered for us, it's not yet defined. It's just probability. So it's not that that experiment was done, a year ago, and that what was on the screen happened a year ago, and therefore it has to be the way it is. It can't change based on whether or not you destroy the detector data. That doesn't make any sense. Well, that's because you believe you live in an objective reality. The fact is that what's on that screen is still just potential. It's never been rendered for anyone. No one's ever looked at it. What's on that screen hasn't happened yet. Well, it's a year later. What do you mean it hasn't happened yet? Nothing enters this reality until the data is required to be rendered here. Okay, so you rendered the data when you measured which slit it went through. Then they had to render a particle for that data.
The man in the tree, I think you're still speaking, though, of probability, and I wonder if you can, and that is a good example, but what I've heard people struggle with is, the nature of this physical reality, how it seems so solid, and it's very difficult, I think, for people to consider that their data stream, that they're seeing this through a data stream, and that this object isn't, maybe different.
What is on the screen is not an objective thing that was put there a year ago. What is on the screen is just potential. It's a possibility of what's on the screen. And that possibility is determined by what data exists here. Okay, now once somebody gets that data out and looks at it, now the system has to render something. At that time, the probability function, if you will, collapses, and the virtual reality has to render something because somebody's looking at the data. What do they render? Well, they render what is probable. Now, if there's data existing that says electrons went through these various slits, then what is probable to a probability of 1 is that there's 2 points, one behind each slit. Now, if there is no such data, whether it was never taken or whether it was taken and lost or destroyed, makes no difference. The system has to render something now, a year later. Okay, it will render what is probable, and if what is probable is natural, in other words, naturally we start with probability. So its probability is like the default state, right? That's what reality is. It's probability. So when we have to render that, there is no data saying that it is anything other than the probability that it is. Then you look at the probability at that time. So at that time, what goes on that screen is put there when you look at it. Before, nothing was there. It was just probable. You see, it was only a potential. It was just a potential pattern on the screen until you look at it. So what we believe is that when we did that experiment a year ago, that's fixed. It can never change. That's solid and it's done. It isn't. Until that result is rendered, it's still up for grabs, if you will. It's just a matter of probability. And what the probability is changes depending on the history, because you have to stay consistent with the history. You can't have things be inconsistent. You couldn't have them render a particle distribution with 2 spots if there was never any indication that there are any particles. Why would it do that? Why would it just suddenly render, particles out of nothing? You see, there's no reason for it to do it. So it gets its default answer, which is a diffraction pattern. So, why is it that we feel that we're in this insubstantial world? I have people write to me and they say, well, look, I'm looking at this tree, and if I shut my eyes, you're telling me the tree disappears. And I say, no, it's not that the tree disappears. The tree was never there in the first place. You are consciousness receiving data, if you will, the image of a tree. Okay, and you interact with that tree because it's a multiplayer game. Everybody looking at the same thing you're looking at gets the same data of that tree, except from different perspectives. So somebody on the other side of that tree sees the side that you don't see, but you see the same tree. It's a multiplayer game. Okay, just like in World of Warcraft. If you walk past a tree, you see the side of the tree, you turn around and you look at the other side, you see the other side of the tree. It's just the way it is. And if there's other players, you all agree on what you're seeing. That's just the nature of a multiplayer game. All right, so when you close your eyes, what happens? You're no longer having the data given to you that has the image of a tree in it. So if you're looking at this tree, it's because you are getting data that gives you the image of the tree. That defining that image of the tree. That's all you have. When you close your eyes, you're no longer getting that data. You're getting data that's describing the light maybe that's filtering through your eyelids, if there's any there. Okay, you're not getting data tree. You open your eyes again, you see the tree. So at night, when everybody goes home and nobody is around in that vicinity of that tree, it's not that the tree disappears, it's that the tree was never there. It was just data given to various consciousnesses. Okay, think of it with the World of Warcraft video game. Okay, it's the same thing. What happens when there are no players in the World of Warcraft game? There's absolutely nobody to play the game. It's just the server, and it's entirely empty. Does that server keep rendering trees and monsters and everything? Of course not. Rendering what? Who would it send it to? When somebody turns on their computer and logs into the game, now suddenly it starts rendering to that person whatever it is that they would see depending on where they are on the map, you see. Now they turn off their computer, and it's not that you say, oh gee, well what happens to that stuff? Does it just disappear? Well, of course in World of Warcraft you don't say that because it's perfectly clear. It's a virtual reality. Of course it doesn't disappear. The computer just isn't pushing that data out to anybody. So it doesn't exist. So you say, well, how is it we live in this insubstantial virtual world? You see, and you know, this table, this is hard, and my fist hits it, and how come it doesn't go through it if it's just virtual? Well, how come you can't walk through trees in World of Warcraft? How come you can't walk through rocks? You have to walk around them. Why? Well, because that's the rule set in the game. The game's rule set says you can't walk through trees. You have to walk around them. The rule set here says, that's wood, I can't put my hand through it. So that's the way it works. But when there's no players, there's no data going out. Look at the World of Warcraft game. It's putting an individual data stream out to every player. Every player gets their own unique individual data stream. So depending on exactly where you're standing and where your head is pointed and where you are on the map, you get a particular data stream that suits you. And even if there's 1 million players in that game, none of them are getting the exact same data at the exact same time because they all couldn't be standing in the exact same point looking in the exact same direction, you see? So we all get individual data. When we turn our head and don't look that way, then that same data we had is not rendered to us, but something else is. So as I look forward here in the room, I see what's on that side of the room, and I'm not being sent data about what's behind me unless I turn my head and look that way. You see, so you just get the information you need and you interact with it according to the rule set. Okay? So that's the way it works. So it's not like I close my eyes and the whole universe disappears. That's impossible. The whole universe wasn't there in the first place. It's just data. You get your individual data stream, and that's, you know, what you appear to see. And you interact with it. It's solid. You can or can't walk through it, whatever, because of the rule set. So if something, you know, if something hits you and you bleed, well, that's because that's the way the rule set works. That's the rule set of your body and your biology. So that happens.
So can you talk about that in terms of virtual realities and what we each individual see when there's an accident and you interview people and they've all seen something different?
That's because they all get a unique data stream seen from their viewpoint. That's number one. They're not all seeing exactly the same thing because they're all not on the same spot. Number two, when they get that data, they interpret it. And depending on who they are, the experience they've had, they interpret it differently. Where somebody, may interpret, somebody may focus on the fact that the driver was swerving. Somebody else may not even notice that because they were focused on the child they were going to run over. They didn't see that they were swerving. They never noticed it because their attention was someplace else. So you interpret things based on what's important to you. What, if it lies outside of your experience, you probably interpret it pretty badly. If it lies inside of your experience, you're better able to put metaphors and symbols to explain it. So you get 5 different people looking at it. You get 5 different viewpoints physically from where they're standing. You get 5 different interpretations based on their beliefs. Let's say there's somebody that believes that it's all those damn, motorists that are aggressive that cause trouble on the road. Well, they might see the fact that they may see that this person was going fast when maybe they weren't. That's just how they interpret it because they just assume it's an accident. Somebody was going too fast. So they'll report, oh, this guy was speeding. I saw him, he was going really fast. Because that's the way they interpret the data. And maybe they weren't going fast. And somebody else who doesn't have that issue will say, well, I didn't think they were going so fast. They seem to just be going, kind of normal speed. But, they'll have their own twist on it. So all the stories have an individual twist based on the individual twists that are inside, each of the people. Okay, so now let's take that and wrap it back down to the double-slit experiment. So in the double-slit experiment, if you have data, okay, that's coming into this reality, it's coming in a data stream to somebody, and the data says there are particles here going this direction through the slits. You can't help but have, if you look at the screen on the back, but 2 points, because what else could there be? You can't get a diffraction pattern then, or it would be inconsistent. Okay, if you don't take the data, so you don't have a machine, then you'll get a diffraction pattern. Why? Because that's what's likely. That's how the light, that's how the particles are likely to distribute themselves, because the probability goes through both slits. Not the particle goes through both slits. You will sometimes even hear physicists saying, well, sometimes the particle goes this slit, sometimes the particle goes through that slit, and sometimes the particle goes through both slits. That's patently ridiculous. The particle never goes through both slits. Particles can't go through both slits. What happens is the probability of a potential particle goes through both slits, interacts with itself, and the probability of where that particle will land ends up in a diffraction pattern. You see? So now, if you take the data for the slit data, then erase it. Okay? If you've erased it, then there is no reason why you should get particles balled up in those 2 spots behind the slits. You think there's a reason because, well, the experiment was done and it hit there and they had to stay, but it's not been done. What's on that screen isn't here yet in this physical reality until somebody gets a data stream that renders that result. That result is indeterminate, hasn't happened yet until it has to be rendered. And until it has to be rendered, it's just probability. So that's why when you destroy that data from the slit data, now you've changed the probabilities of what might be on that screen, because no one's looked at that data yet, so it's still just indeterminate probability. And you've modified the probability of what it will be by destroying that data. Now when you look at it, you get a diffraction pattern. You see, because there is no data that says that it shouldn't be a diffraction pattern, that it should be spots. So you've changed the probabilities now so that when you look at that later and have to collapse the wave function on those probabilities at a later time, the probability is different. Your mistake is thinking that when you did the experiment, it was all done. You had a fixed result at the detector and a fixed result at the screen. And now you erase the data. How can you change the fixed result at the screen? You don't have a fixed result at the screen. All you have at the screen is a probable, indeterminate event. You don't know what it is yet until somebody looks. And if you look and there's data here that tells you that it must be particles, you'll see particles. If you look and there's no such data here that tells you that it'll be particles, then it's not going to be a particle, because the system doesn't just pop particles out of nowhere for no reason. And the data is the reason that it needs. You see, so that's how that works, and that's why that's very confusing. So now so it doesn't have to do with the fact that somebody, some consciousness, looked at the data going through the slits, and then that fixes it. It doesn't matter when anybody looked at it or not. It only matters whether that data exists. That data could be inside the memory in that machine. And then you go look at that screen, and that screen will say that it's particle, because there's data that's been taken, it's been rendered into this reality that says it's going to be a particle. So it can't show you a distribution, a diffraction pattern on the screen when you've got data sitting here in the same reality as that screen that says it was particles. See, that's inconsistent. But take that data away, and the probable future, which is what that data on the screen will look like, is now up for grabs. You see? So when you go to look at that screen at a later time, you'll see the diffraction pattern, because there is no information contrary to that. And that's the natural state of things. All reality is probable. And the man walked into the woods. Why did he see the wobbly dead tree? Because it was probable. He came back in the woods later. Why did he see it laying on the ground? Because that's what was probable. Now let's say he makes a measurement. Let's say while he's there in the woods and he sees this dead tree that's wobbly, he ties a string to that dead tree, ties that string over to a camera, ties the camera, the button that pushes the camera, he ties the string to that such that if the string gets pulled, the button will be pushed and the camera will take a picture. Or maybe he'll start a movie camera running, turn the off-on switch. He says, all right, I'm going to come back and I'm going to catch that tree and I'm going to watch that tree fall on my camera. Okay, so he leaves the woods and he waits a long enough time and thinks for sure it would have fallen over now. Well, what happens? When the probability that that tree falls over, why? Wind, rain, rot in the wood, whatever. When the rule set says that it's very likely for that tree to fall over, then that probability gets very high. And when you take that random distribution, random draw out of that distribution, you're more likely to get the tree falling over then because the rule set makes its probability high. So, okay, that happens. When it's very probable that the tree falls over and that probability goes to 1, and that's basically the draw you get, the tree, then the rule set says that the way things fall here is that they go like this, the string gets pulled. Because of the rule set says that if you pull that string, then you're going to flip that shutter, you're going to turn that switch, you can turn your camera on, and then the rule set says that because of gravity, see, gravity is part of our rule set, trees, strings, buttons, electronics, batteries, all that's part of our rule set. So you will see a movie of the tree falling down on the ground. And if you have a microphone, you'll hear it. Why? Because that's probable. You see what I mean? It's probable that when you pull the string that you're going to flip the switch. It's probable when the switch falls, when the switch gets flipped, that the movie camera is going to start. Why is it probable? Because that's what the rule set says. These are just things that abide the rule set. So because of all the probabilities, when the tree starts to fall because that's probable, then the string gets pulled because that now becomes a probability of 1 that the string will be pulled. Now it becomes a probability of 1 that the camera will turn on. Now it becomes a probability of 1 that it will see the tree falling in its stages, because what happens? Every delta t, right? You go into the probable future and you pull out what's probable. Well, once we got to the probability of it starting to fall, the next delta t, guess what? It's just leaned over a little bit. And the next delta t, this is the rule set. It's leaned over a little bit. And the next delta t, it's leaned over a little more, next delta t, and it's making noise. Noises are generated because fibers are being torn and things are happening which produce acoustic vibrations, which can be recorded on a microphone. So the rule set then follows along. Every delta t goes into the probable future and says, well, what's probable now? Well, we've got this tree that's falling. What's probable now? Well, it's going to be a probability of 1 that it's going to fall 1 delta t more. What's the probability now? Probability of 1 that it's going to fall a delta t more. Why probabilities of 1? It's the rule set. See, the rule set tells you that all those things are probable. So yes, he comes back. He sees a dead tree on the ground. Why? Because that tree is rendered to him on the ground. That's why he sees it. He goes, looks at his movie, and he's captured a picture of a tree falling over in the woods. And he can have his camera with a date, time, and a GPS, location stamp and time stamp, and he can see just exactly, the second that it began to fall and when it fell and when, whatever, because the rule set dictates that that's the process that has to happen in this virtual reality. And that's because of probability. Suddenly, a whole bunch of things, probable things, turn to probabilities of 1 when the tree starts to fall. The string begins to stretch. The switch begins to turn on. The motor in the camera begins to run from the battery. All of those things now suddenly get a probability of 1 as delta t after delta t comes down. So that's how that works. So you see, our whole environment, our whole life, everything we do is no different than the double slit. Every interaction we have with somebody, it's because that delta t, something was probable. And of all the things that were likely to happen, we reach up and we pull out a random draw from that. Now maybe that distribution was a square distribution. They were all 1s. That's the way it is when that tree was falling. There was a whole bunch of things that now had 1 probabilities for all the consecutive delta t's. So that may be a given. So you reach up, you pull that, and that's then what happens. And we're in a multiplayer game, so it all has to fit together so that there are no inconsistencies in the reality for anyone, and nothing is set, nothing is done until it's rendered. Once it's rendered here, it's a part of our history, then it must be consistent with what happens next. So those are kind of the basic rules. It's not really consciousness that collapses the wave function. It's not even actually the measurement that is the key. The key is information. Of course, consciousness looks and makes a measurement, and that measurement is information. So we can kind of confuse all those things. They all look like they're sort of the same thing. But if you get down and look at the details, it's all about information, and it's all about consistency.
So the double-slit experiment shows that this reality is probabilistic and statistical.
Exactly.
And that defines a virtual reality.
Exactly. So that's what's important about the double-slit experiment. It is something that just as clearly and obviously as can be tells you that the only way this experiment makes good sense is that if we live in a virtual reality that is informational, and that it's a probabilistic and statistical reality, so that what's at the screen is indeterminate. It's not really done yet until it has to be rendered, until somebody looks. You see, that's when it has to be rendered. But it's all about information. So yes, that's the key thing. Now they've just done, I just read on the internet where they've done an experiment now with entanglement. They have two sets of entangled pairs, and they take, let's say 1, 2, and 3, 4. So they take maybe 1 and 3, and they put those in a detector, and they see how they are. Then they let the other two go, 2 and 4, and later on they do something with those that creates an entanglement between those two or not. And then what happens, they find out if they create an entanglement later, then the two that they already had measured and tracked, they're entangled too. And if not, they're not. You see, and it's the same backwards causality thing. How come it is that what I do later affects what I did now? Well, what they will find is the same thing as the double slit. It's just the way reality works. It depends on what information is here when, because that's what determines what the probabilities are and what the historical consistency is. So if they do this experiment, and then after they're done making the later change, they come back and look at what they have now, well, that will have, it looks like that will have changed in order to fit what they did later. Well, it didn't change. It hadn't been decided yet. It was still up in the air, if you will. It hadn't been rendered yet. So it was still just probability. And then what they did later modified the probability when then they finally looked at the original one, you see. So it works the same way. But now, of course, they see this as a completely different sort of thing. It's just a double-slit experiment done, in a different way. And they'll find it's just newly done experiment, they'll get better at it, and they'll find that it works just like the double slit. And it's the same way. If they record that data and then they destroy it, they'll find out that these things then will show that the data doesn't exist. But they haven't done that yet. But if they will, it'll work out that way. You see, it's just the way reality works. It's the way reality works with trees in the woods. It's the way it works when you go do anything. You get in your car and drive to work. Delta T to delta T, what is probable is what happens. And until it's rendered, it's still just probability. The old thing about Schrodinger's cat, put the cat in the box. And then you have a radioactive source that decays randomly. And as it decays, if it just happens to decay in a particular direction, it causes poison to go into the box. And is the cat, dead or alive? Well, you don't know. You see, it hasn't been measured yet. So the answer to that is the cat's in an indeterminate state. It's neither dead or alive. It's not until you open the box that you will get a result that best describes the probability of that situation. So if you know that this random decay happens in such a way that within 6 months it would have decayed in every possible direction, that means within 6 months it definitely would have hit that particular detector that would have created the poison, then the probability is that all the cats are dead, right? The cat would be dead. That would be the high probability. Well, that's what you're likely to find. So if you did that with 10,000 boxes with 10,000 cats, you'd find that, maybe 9,800 of them were dead. And what's the probability that it would just happen to miss in that amount of time? Well, maybe it'd be one in 1,000. Well, then you'd find 10 of them that weren't. You see, it's that kind of thing. And then everybody would say, well, sure, that's just physics, that's just statistics. It's what you'd expect. It's exactly what you get. You see? So that's the way reality works. Until the data is rendered some way here, whether it's rendered to a machine that we can look at the data later, or to the camera, or to a person, doesn't really make any difference. You see? So
that's where your subjective reality doesn't need to come in to the double-slit experiment. You're saying that consciousness doesn't need to come into the double-slit experiment. It's the information.
It's the information. Because when you take that device that has the data and nobody looks at it, okay, it doesn't matter that nobody's looked at it. It's there. Therefore, you'll have to get the 2 spots on the screen because you have data here to prove that there were particles. The data's there. Okay, but now let's say that somebody made a mistake and they didn't actually get any data for some reason. The hard drive failed in it, or all the ink ran out of the pen or something, and there was no data. Well, if there's no data, you'll get the diffraction pattern, you see. And it may be that nobody knows whether there's any data in there or not. But if the probability is that the data is there according to the rule set, in other words, the rule set said that there's plenty of ink, the memory's working fine, there's not much of a probability that that would fail. Again, it's all probability. So it all works out. It all works out with reality being virtual, with reality being probabilistic, and then suddenly all these things make sense. And no, it doesn't mean that this table disappears because I'm looking over here and can't see it now. It just means that I'm no longer getting table image into my data stream. You, sitting over there, Donna, still see the table, whether I look over here or not, because you are getting it. Because it's a multiplayer game and we have to have consistent reality. All the virtual reality games, work the same way. So it doesn't confuse people when you say, well, look, what if there were no players in World of Warcraft? What if one day nobody showed up? Well, what would the server be rendering? Wouldn't render anything. There would be nobody to render it to. It only renders when somebody asks for the data. Somebody turns on their computer, it starts rendering whatever's going on there. But if they don't ask for the data, it's just all the trees and rocks and monsters in World of Warcraft are just potential trees, rocks, and monsters. You see? They're just potential things. And it's not until somebody asks for that rendering, for that data, does it then appear to be a real thing to that person, because it gets rendered then to them. Everything in our reality is just potential until we interact with it. But it's a multiplayer game, so it's not like I can turn around and then that disappears for everybody. It only disappears for me. But the point is it's not really here in the first place. This little flower is not really here. It's just data. I'm getting the data, you're getting the data, we both see it. Everybody in the room is getting that data, and they see it because it's a multiplayer game.
And we're subject to the same rule set
We're
that it
subject
has.
to the same rule set. So we all look away from it. We look back. We're not going to find a big giant toadstool in its place because it's here. The data is here because it's been rendered to us. It has to stay that way according to the rule set. Now maybe these flowers will fade, or maybe they'll turn brown, or maybe the dye will leave them or something. Well, that's according to the rule set, and we'll all agree on that. We'll all see it. So the idea that this world is really insubstantial, it's virtual, it's just data, but that's impossible because here it is. Think of yourself as being a character in the World of Warcraft. Those characters have the same issue, To them, the rocks are solid. The rivers, you sink if you don't swim. If you do, you drown. You fall off a cliff, you get hurt. You know, they have all the same things. They can't walk through trees. They can't, do things. But now their rule set may allow them to fly or leap or teleport or something else because their rule set allows that. Ours doesn't. Ours is a better game, more detailed game. We follow this rule set.
It's interesting you use the word insubstantial. I've always thought that poets had great insight into the nature of this reality. That's another way to interpret it, other than science. But Shakespeare said, "This insubstantial pageant faded."
Mm-hmm. Yes, you hear that a lot from poets. You hear it a lot from various theologies. You'll say, what do you hear at both Buddhists and other Eastern religions will say that it's all maya, it's all illusion, right? It's the same way. You'll go to the Hopi Indians and they'll say, we're living in a dream. We wake up from the dream when we die. They're all basically getting at the same sort of thing. This is not fundamental. You see, it's not that it's not hard in here, it's just not fundamental. What's fundamental is consciousness. What's fundamental is the server, if you will, in the virtual reality. If you're in a virtual reality and you're a character and you're an elf and you're walking around, well, yeah, the rock is there, and no, you can't go through it, and yes, if you run into it too fast, you'll hurt yourself. And if it's a real detailed simulation, you may tear your skin and bleed and other things, and you have that, but the rock is really not fundamental. What's fundamental? The server is fundamental. That's the origin of the rock, right? The rock's just data. Well, that's the way it is here. So yes, all of these people have figured that out, and they say it's all illusion. It's the dream. It's insubstantial, and
we are such stuff as dreams are made of.
Yeah, right. So you have these analogies that have the basic truth of it, and people kind of know that seems right. There's a part of us that understands that there's a non-physical, a spiritual, a larger dimension to life than just the physical. That's kind of a gut instinct in most people. Now some override that instinct with their intellect and say, bull, if you can't measure it, it doesn't exist. But that understanding is there, and that's why we get this out of literature and poetry and philosophy and theology, because that's true. And you have to let go of your belief in an objective physical reality in order to see the bigger picture, which is a probabilistic, statistical, virtual reality. And once you realize that, you'll see that everything works just the way it is. Not that physics doesn't work anymore. You're not suspending, well, if it's a virtual reality, I could just float up to the ceiling. No, the rule set says you can't do that. No more than you can walk through walls or flap your arms and fly. It doesn't work.
Well, thank you. I think you've very well clarified the importance of the double-slit experiment.